So once there are brackets, you are literally, yeah, you have that. Now, mind you, there is a, I want to say there is a unspoken rule about, let's say, something like, what if you had 3a raised to the 2? Oh, hold on. I don't want it to just be that. 3 to the 3 times a raised to the 2, all of that raised to the 4. Now the reason why this is important is because I don't think a lot of people pay attention to this aspect of it. So yes, it's true that you're still going to have 3 to the 3 times 4, but also you're going to have a raised to the 2 times 4 as well. So then now in this case you're going to end up with 3 to the 12 and a raised to the 8. So you had this. Yeah. So the second part is an unspoken rule in indices. So meaning you're not just raising this to the 4th, you're raising everything in the bracket to the 4th as well. So everything that's on the inside of the bracket gets raised to the 4th. Believe me when I tell you, a lot of times that gets overlooked. So if you're teaching this, you should also teach this. Right? That's yeah. Because that will trick you if you're not prepared for it. Now, what's the other rule that's very important? The other rule that's important is, and this one is fairly straightforward, and it goes like this. Any number that is raised to the 0 is equal to 1. It makes sense if you think about it like this. Remember the rule about this? There's a rule where you have 3 raised to the minus 1, right? And that is the same as 1 over 3 to the 1, right? But what's the joke? That is 3 to the minus 1. What about 3 to the positive 1? Well, that's the same as what? Just, you can write it the same, whether you can write it as 3 or 3 to the 1. It don't matter. Right? Whether you say 3 is equal to whatever. Yeah? You can do that. Now, there's a reason why I put these two together. Because a substitution for this, 0. 0 can be replaced by what? 1 minus 1, 2 minus 2, etc., etc., right? 5 minus 5, whatever. But let's just focus on what we have here. The 0 equal 1 minus 1. It basically means that you can replace the 0 with 1 minus 1. But if you were to separate these exponents, it would end up looking like 3 to the 1 times 3 to the minus 1. Yeah. So this is the same as saying 3 to the 1 times 3 to the minus 1. But we know that 3 to the minus 1 is that 1 over 3 to the 1. So if we replace that with this, and then you divide this by this, then any number raised to the 0 is always equal to 1. And it don't matter what it is. So it could be 1 million raised to the 0, 350 raised to the 0. Anything that's raised to the 0, all is equal to 1. Every single time. Now there are other important indices rules. Another one. It's the ones related to what we do in changing the subject of the formula. So to put a long story short, the square root of a is same as a raised to 1 over 2. The cube root of a is the same as a raised to the 1 over 3. Now there are times when they get a little bit, what's the word now? They get clever with these a lot of the time. Because sometimes they say, well, what about if I wanted you to find a to the 3 over 2 and a to the 2 over 3? What would that look like? Well, imagine it like this. What you had before was 1 over 2. Well, if you were to separate that, the a raised to the 1 over 2 has a 3 on the outside. And the a raised to the 1 over 3 has a 2 on the outside. So what that basically means is, the first thing you do, cube root it, then square it. Or, first thing you do, square root it, then cube it. Right? Now, mind you, I have to be careful, right? Because that means square root the number first, and then the result of it, you cube it. Right? So square root first, cube it after, cube root it first, square it after. So we want to be doing that. So a lot of this